this lovely hall. We are from Zhongling High School, and it's an honor for us to be standing here to present to you our project entitled Eco-Paint and Adhesive from Polystyrene Waste. Well, before we get into the main point of the project, allow us to introduce ourselves. I'm Yishan. This is Zhihan, and this is Sao Chen. And our tutor and teacher advisor, Ms. Wong Yin. So, what is polystyrene? So, I believe just now we have just used this polystyrene cup. So, if these polystyrene cups, numbers of these polystyrene cups increases, what is the implication? So, besides that, we also use polystyrene containers. Most importantly, protective packaging. The uses of protective packaging in the field, the uses of polystyrene in the field of protective packaging increases daily. So, what actually polystyrene is? Polystyrene is a synthetic polymer made from a liquid petrochemical monomer known as styrene. Being non-biodegradable, it remains intact as a waste for centuries. Being voluminous, it occupies available landfills and pollute our environment. So, the process of recycle for this polystyrene has been limited. So our main idea here is we could dissolve this polystyrene using our limonene. So this is our project, we call it as Eco-Paint. So a lot of you must be wondering, what is Eco-Paint? What basically make our project? Well, our project is mainly made of two main components. They are polystyrene and lemon peels. Well, as you all know, these two components are classified as waste. So these two ingredients are precisely the things that we use to make our Eco-Paint.
Okay, so the main ingredient for this, the main secret for Eco-Paint is this substance, limonene. So what is limonene? Generally defined, limonene is a kind of essential oil or fragrance oil that can use to make perfumes. So how can we obtain or extract this limonene from? Okay, limonene can be extracted from citrus fruits, vegetables, meats and spices, but mainly in citrus fruits. And also maybe you're wondering why we are going to use lemon peels over oranges. This is because this lemon actually has a higher percentage, maximum percentage of this limonene. So this is the IUPAC name for this substance, limonene 4-isopropanol 1-methyl cyclohexane, and this is the molecular structure of it. So the main idea in our project is that this limonene extracted from the lemon peel can dissolve polystyrene. So but how? How can we achieve that? So let's compare the structure, the molecular structure of this polystyrene with limonene. So on the left, you can see here, is the limonene. On the right is the monomer of the polystyrene. So the similarities of these 6 membered rings, which allows the particles in the hexagonal structure to rearrange themselves, and this is what we call the dissolving process. So how can we achieve all of this?
So our problem now is how can we extract limonene oil from our lemon peels? So we can just do it by a simple distillation process in a laboratory. So firstly, by using a knife or peeler, we remove the rind from the pith of lemon peels. After collecting the rind, we will subject it into a blender. And we will add some water in it and blend. And after we collect the mixture, we will subject it into a round bottom flask and into a distillation set. at around 98 to 100 degrees Celsius. So after 5 hours, we'll get about 100 ml of distillate in our conical flask. So we'll get the distillate into the burette and let it settle down for a few minutes. And we'll let the aqueous layer be at the bottom of the burette and the oil layer on top of the aqueous layer. So after we ran off the aqueous layer, we'll collect the top oil of our distillate and store it into a cool, dry place, in our case, the refrigerator.
Okay, so now we proceed to our second part of our experiment, that is the test for limonene as a solvent for polymers. Okay, as you can see, we use the limonene we extracted from the simple distillation method just now, as my friend just explained, and we pour it in a beaker. After that, we try to dissolve it use polystyrene to dissolve in it. As you can see, there are some gas bubbles over there. This indicates that effervescence occurred, and this gas released is styrene gas. Actually, styrene gas is quite poisonous, so the whole experiment, we carried it out in a fume chamber. So what do we learn from this part of the experiment? We learned that perspex and polystyrene are soluble in our limonene, while other organic solvents such as methylbenzene and propanone, they are not quite as eco-friendly as our limonene.
So for part C, we are investigating the time taken for the limonene polystyrene product to dry. So instead of just producing one kind of product from the limonene and polystyrene, we are trying to make variations of our product by setting up this ratio, limonene to polystyrene ratio. You can see we use 1 to 4, 5, 8, 10, 15, and 20. So one unit of limonene represents 1 ml of limonene, and as for 1 unit of polystyrene means that it is 1 cm cube of polystyrene. So 1 to 20 over there, it is the saturation point for this ratio. That means 1 ml of limonene can maximally dissolve this 20 cm cube of polystyrene. So as we add more polystyrene, the viscosity increases and the approximate time taken for it to dry will also increase. So from the table we can deduce that this 1 to 8 ratio is the golden proportion for this wood coating ecopane because it is moderately viscous, and the approximate time taken for the dry is 5 minutes, which is like an average wood coating on a shellac. As for the 1 to 15, it's suitable for perspex adhesive ecopane because it is viscous enough.
So now we go on to our fourth part of the experiment. That is the test for our properties or functions of our ecopane. So the first function we tested out is the function of waterproof. And how do we carry out the experiment? So we use one piece of wood that is coated with our ecopane, and we drop water onto it. And the observation is compared with the control set, which is a piece of wood with nothing on it, without our ecopane. So what do we observe? We can see that water droplets spread out on the control set, which is not coated with our ecopane, while the water droplets aggregates to form a globule in our wood coated with ecopane. So this denotes that ecopane is waterproof.
The next function of our ecopane is it provides a fire-resistant properties to our wood. However, our ecopane is not fireproof by itself, so we add another ingredient in our ecopane, that is sodium silicate, which is sand. But how can we do it? So first, we apply a layer of ecopane onto our wood and let it, before it dries, we apply a second layer of sand evenly onto the ecopane and let it dry for a while. Lastly, we coat the ecopane at the final layer by sealing the sand and the wood together. Next, we subject the control set and the one with our ecopane coated to Bunsen burner, and this is the observation. So the treated wood did not turn black, char, or catch fire, but the control set turned black and caught fire within 5 seconds.
Okay, so this is our third property or Ecobin, which is Perspex adhesive. So we use an unused Perspex and glue them together with a ratio of 1 to 15 with our Ecobin, and we left it to dry for about approximately two days. So these are some pictures we took in this particular experiment for the test of the Perspex adhesive properties. As you can see, the glued Perspex is inseparable, neither spring balance or brute force. That means the spring balance actually maxed out before we are trying to separate the Perspex.
Okay, the last property will be the insecticide property. So as I mentioned before that limonene smells good. So we actually applicate this smell so that limonene can be this Ecobin can be an insecticide. So we actually tested it out by an experiment using petri dishes and also some ants. Okay, so this is the table. We use 3 petri dishes, A, B, C. For A, we will put water only. B is water and detergent. C is the water, detergent, and distillate means that it is the distillate, the water component from distillate, from the simple distillation process that we use to extract the limonene. So as you can see, for the first and the second petri dishes, the ants were unaffected, and for the last one, the ants stopped moving and curled up in just 7 seconds. So why actually we use detergent over here? Just for information, detergent is a surfactant liquid that allows this limonene and also the water to emulsify. So but how? Limonene is used as a botanical insecticide nowadays, and also particularly enantiomer is most active as an insecticide. So this enantiomer is a kind of a general definition of a kind of substance that, like drugs, which is able to affect the physiological processes of a living organism. So what are the implications from this research?
So through the whole experiment, we found out there are different ratios that are optimum for different properties. So the first ratio is 1 to 8, which is 1 ml of our limonene to 8 cm3 of our polystyrene. So the properties that are suitable for this ratio is waterproof and fire resistant. The second optimum ratio is 1 to 12, which is suitable for our insecticide properties. And the last and final ratio for our Ecobin 1 to 15 is suitable for, it can form a strong adhesive for Perspex.
Okay, for the commercial value of our Ecobin, okay, according to the information here, 1 liter of limonene costs $20 US, or equivalent to 60 ringgit Malaysia. So for example, 1 liter of limonene can produce 1000 ml of Ecobin. Each ml can dissolve 20 cm3 of polystyrene. So according to the price above, 1 ml of Ecobin only costs 6 cents.
So as a conclusion here, I believe that the super glue that you can buy outside at the marketplace will cost around 3 ringgit for 5 ml a bottle. But in our case, the super glue for 5 ml of our Ecobin will only cost 30 cents. That is 5 times 6 equals to 30. And after adding the profit, it will cost only about 1 ringgit, and it is very cheap.
Okay, and secondly, the characteristic of our Ecobin is it is abundant. As you know, the components we use to make our Ecobin is actually classified as waste, the lemon peels and the polystyrene. So they can be found anywhere. So it is considered as abundant. And it is eco-friendly because we actually gain benefits from these two waste that's considered it can pollute our earth So we are trying to gain benefit from two harmful ways. And the fourth characteristic is it is multi-purposing. As you can see, we just showed you some properties or functions of our EcoBin. And last but not least, it is simple, not sophisticated, and yet an innovative idea to benefit mankind.
So I will make a conclusion here. So we will get the lemon peels that is categorized as a waste, and we will extract the limonene oil from the lemon peels. And after that, we will just dissolve the polystyrene, and it will become our EcoBin. And we can use the EcoBin in a certain ratio for our function that is shown you just now.
So basically this sums up what we're going to share today. We thank you all and we hope this sharing, you appreciate our sharing. Thank you very much.
Thank you participants for your interesting research. And now we have a 3 minutes Q&A session.
Yeah, you look very, very young. So I have something to ask. I'm just very curious. Your project sounds fantastic. You will solve the environment and so on and so forth. So you would be going further in life. So with this project, are you going to carry this forward, or how are you going to develop it further in future and so on and so on? Do you have any, how to say, future plans for it?
For now, we are actually trying to finding ways to applicate this EcoBin. We are trying to actually just a few weeks ago we are letting the EcoBin itself to dry according to the ratio of 1 to 10, so that we can make plastics of it. Yeah, plastics. We put it into a petri dish and we allow it to dry, and a layer of like transparent plastic will come out of it after it's dry. So as for your question, I think that we can maybe commercialize the whole process, because this is just a simple distillation process. If we do it in industrialize it, the control pressure and so the control temperature will definitely increase the productivity of limonene, and we can use this to reduce the polystyrene waste, which is very severe nowadays because of the our very concentrated our usage nowadays. So, did I answer your question?
Okay, I got a question for you. I'm here. Hello.
Sorry.
It's okay. Okay, just a question. Why do you call it EcoBin? Why do you call it EcoBin?
Okay, eco because it's eco-friendly. As for pay, actually it's quite confusing, but the pain is just a term.
Because it's not actually paint.
Yeah, because it doesn't have paint pigments, right?
Yeah. So how do you guys came up with the name of EcoBin?
Paint is just a term to represent like shellac, like a good coating. Yeah, that's our idea.
Okay.
Hi, I'm Gordon Cheng. I have a question. I'm quite interested in, like, because you say that how to say, your limonene can actually dissolve polystyrene because of the 6-member rings. Do you mind sharing with me how does it dissolve the dissolve the polystyrene with these 6-member rings? Does it work with any kind of compounds that have 6-member rings as shown?
So according to a study that organic solvents can dissolve this organic compound, right? So especially the 6-member rings, which is according to what like dissolve like theory, which allows this reaction is possible. As for your question, you're asking.
Yeah, because you say like organic solvent will dissolve organic compounds, right? So because a lot of organic compounds are actually organic solvent. So does it mean that any kind of organic compound can dissolve polystyrene? Or is it just this specific functional group of the 6-membered ring that actually allow the dissolution?
应该是指这个问题，因为如果说不是的话，应该是要去找不到。
So actually, any organic solvent that has the same member rings with this polystyrene can dissolve it. But for limonene, it's more eco-friendly rather than other organic solvents such as I just mentioned just now, the methylbenzene or propanone. So it's considered as a better option than other because it is more eco-friendly.
Is it because of the byproducts? Because as you say, for the reactions, right, poisonous gas of styrene gas is produced, right? So does it still make it eco-friendly in a way?
This is because polystyrene itself is, yeah, we know poisonous, right? When we any effervescence occurs. But the main point is that this limonene extracted from this organic material, which is the lemon peel itself, it is eco. The point is that we can dissolve this, reduce this polystyrene waste. So what we are going to change is that we use a different kind of solvent. This is far more better.
Okay, thanks for answering.
Thank you.